Okay, so let's start. So I just wrote this up here as kind of a just big picture. So the big picture is the whole reason it's easy to factor when the lead coefficient is 1 is we already know the first half of the two binomials that we're getting. We already know that the first one has a 1x plus something, and the second one has a 1x plus something. Right? If the lead coefficient isn't 1, the reason it gets hard is instead of just searching for the second number and already having this first one set, you need to now check every combination of the product being this and the product being this and see what the middle term is. So I listed all the possible combos. There's 2 options here, and there's 3 different options here. So you got to combine each of these 3 options with each of these and do it in reverse order. So you get 6 possible combinations and then the reverse order. So you get 12 possible combinations. So the way most books suggest how to factor a problem like this, which will show up pretty often, is this brute force guess and check. So you would write every combination and you would multiply these 2 together, see what the middle term is. Nope. Multiply these 2 together, see what the middle term is. Nope. Multiply these 2 together, see what the middle term is. Nope. And go through all 12, multiplying them together to see what the middle terms are. They sometimes call it a box method. They draw a little box and it's still just guess and check over and over and over. Some people love that method. If that's the method you want to do, awesome. Use it, okay? I won't teach it to you. The book's got it. I mean,
just the box method, just it's kind of similar to the floor.
Yeah, the box method is what a lot of teachers will teach. It's essentially just the same thing. It's saying, okay, well, one combination is 1x minus 1, and that would be multiplied by 6x minus 12. Okay. And we know that x times 6x is 6x squared, and negative 1 times negative 12 is 12. And we know both of these have to be negative, but we don't know where the factors of 6 go and where the factors of 12 go. So it could be negative 1 and 12 with the negative 1 with this, the 12 with this, or the 12 with that, and the negative 1 with that. So we got to try every possible combination. So you do 12 different boxes and add up the like terms, right? I think that's a terrible method. And it just happens, I wrote it in order, starting at 1, and then going to 2, and just going in order. And this was the actual answer, I believe. So it would have taken you 11 guesses of multiply it out before you got there, just in the order I happened to write it in. So I learned this other method way back in, I think, maybe high school, and I haven't encountered that many people that know it since, but I just love it, because to me, as a mathematician, I hate guess and check, right? There's something so just crass about it. It's not, you know, in math, it's all about elegantly, you know, like carving away everything and solving for, and, you know, the analogy I thought of for the boarding class was it's like taking a ballerina who's so graceful and stuff, and just asking you to like kick a cement wall or something. It's just so like, that's so brutal and not elegant, right? So I mean, guess and check is just such like a hammer, you know, and it's so, I don't know, mechanical. So I'm going to teach you a more systematic approach, where we can use what we just did in 6.2 with a few additional steps. Plus, I give it a fun name too, so that's always good. So here's an example of what we're going to do, okay, or why we're going to do it. Okay, so here's 2x squared plus 5x plus 3. It starts out pretty easy. The guess and check here wouldn't have that many possible combos, because this is prime and this is prime. So our only possibilities are 1 and 2, and 1 and 2. And they're both positive, so there isn't even the positive negative thing. So total, there's 2 combinations. So guess and check here wouldn't be so bad. However, as you get deeper and deeper, and you get to like numbers like 80 and 120 that have a bajillion possibilities, you want a better method, okay? So, right now, we know this is equal to 2x plus something times x plus something, okay? We know that because 2 is only made of 2 and 1, okay? So what we do, since these two are different right now, we can't use our x factor method, which we love, right? So what we're going to do is we're going to make them the same. So what we do is okay, so we multiply in temporarily because we take it out, but to make our solving easier is we temporarily put in an extra lead coefficient. And then at the end of the problem, we take it back out. But by putting that in, what we get is, just to show you, I'm going to multiply in an extra 2. So I'm going to go 2 times 2x squared plus 5x plus 3. And I'm going to get 4x squared plus 10x plus 6, which now will factor into 2x plus something, 2x plus something, and now these are the same. So we can x vector. Okay, so the big idea is if we put in an extra lead coefficient, then we know both of these have a 2. Because we know there was 1 2, and we put in a second 2 for the express purpose of now they both have the same coefficient. So awesome, now we can factor. So the whole game we're going to play today is put in an extra lead coefficient, do some solving, and then take it back out. So, I really like this name. I like making like grown people come up to me and ask for help with this. So what I call it, since we're putting something in, and we're shaking it all out, and then we're taking it out, I call it the Hokey Pokey. So, right, and big picture, this is what we're doing. So as an abbreviated version, we're multiplying in the lead coefficient x factor with, and this is going to seem confusing because this is the abbreviated version, you can put a big box around this, x factor with the old middle term, and new last term. 3 divide out the lead coefficient, right? So we put in the lead coefficient, we x factor, we take out the lead coefficient, okay? And I'm even going to add okay. So that's our nice abbreviated version. I'll write a bigger, more straightforward approach. Again, the sad part is this method isn't like on Khan Academy, it's not in the book. I wish you had more resources. I searched online, but since I made up the name Hokey Pokey, it's hard to find things about it online, but I heard one site refer to it as the AEC method, because when we write out polynomial, the first is A, the last one's C, you multiply AC, but the AC method is actually something else. So I put up one link on the homework site, or on the class website, to a website that also uses the same method, but that's it. Video, notes, and that one link are all I could find. But I should scour the interwebs one more time and try to find it. Okay, so here's how we do it. Here's number 2. Same problem we already did. We're going to do it now with the Hokey Pokey. Okay, so here are the steps. First step. Factor out a GCF. Yeah, this one doesn't have a GCF. Okay? Now, if the lead coefficient is 1, then x factor. That was 6.2, that's what we did. If it's not 1, Hokey Pokey. This is the mental check you go through every time we start a problem. First, is there a GCF? Nope. 2, what's the coefficient? Oh, it's not 1? Then I gotta do the harder method. That's a little frustrating. I like it when it's a 1, it's easier. Okay? But okay, so step 3, we're gonna do it now. Multiply the whole polynomial by the lead coefficient. Okay, so the lead coefficient here is?
2.
Yeah, so let's multiply the whole thing by 2. 2 times this is, hold on. Okay, so 2 times this we get, I'll put it right here, 4x squared plus 10x plus 6, okay? Boom, got it. Step 4 is factor using the x factor, or you can just say x factor, using the old second term and the new third term, okay? So in other words, here was my old, here was new, okay? So the 2 that I'm going to use are this positive 5 and this positive 6. The reason behind this is a little too technical. I don't think it would benefit us to go into the why. Okay, but this is a great method. So now we just do a normal old x factor here. So what's my sum?
5. 5.
Yeah, positive 5 and
Positive 6.
positive 6. And shoot, I meant to write a different step in the middle there. Oh, I don't want to erase. I'll just say step 5. Ooh, I meant to write that. That's bad. Okay, I'm gonna. No, I'm gonna leave it. Okay, step 5. That sucks. I meant to write that in the wrong order, or in the other order. What I meant to write is write out the general form. I meant this to be step 4. That was my bad. Where both binomials have the lead coefficient on their first term. So in other words, the general form here, the entire reason we multiply in the lead coefficient is now we know our product is, I need to get another blue pen. Our product now is 2x plus something times 2x plus something. That was the entire reason we put in an extra 2, okay? And now we're gonna do a normal old x factor with the 5 and the 6, so what are our numbers?
2 and 3.
Yeah, positive 2 and positive 3, so going over here, we get positive 2, positive 3, okay? And our last step is divide out the lead coefficient. And in a separate color here, I'll just write the easiest way to do this is to factor out the GCF from both binomial factors. In other words, once you factored it like that, we know we have an extra 2 in there. We put the extra 2 in there. Okay, and we'll do lots of examples of this. So we're gonna say this whole thing divided by 2, actually I'm gonna write it down here. Okay. So it matches right next to step 6, we have 2x plus 2, 2x plus 3, and we're gonna divide the entire thing by 2. Because we put in an extra 2, that's the whole reason we call it the Hokey Pokey, right? Put in the lead coefficient, shake it all about, take out the lead coefficient. Okay, so we put in the 2, factor it using x factor, now we're taking it out. The easiest way to do that is to say what's the GCF of this one? 2. What's the GCF of this one? 1. So just factoring that, we get 2 times x plus 1 for the first parentheses, times the second one, there was no GCF, divided by 2, and sure enough, look, it will always cancel out because you put the 2 in. So unless you make a mistake, you will always be able to take the 2 out. And so your answer is x plus 1, 2x plus 2. Okay, so really it's only 3 steps. It seems a little complicated. Okay. Again, to start, you multiply in the lead coefficient. You use x factor to find your 2 factors are 2 and 3. You go over here and write out the general form, which has a lead coefficient to start by each one. You say 2 and 3, and then the last thing you need to do is just take out that 2 that you put in. Okay? So let's do a couple steps or a couple problems together, okay? I'll do a problem here, I'll leave the words and I'll just do a different problem. So
did you just move the 2 outside on that one?
yeah, so what I did is I rewrote this in the same place, just as 2 times x plus 1. So I think the easiest way to divide by 2, the safest way, is to take out a GCF and just rewrite the whole thing as is, and that way you can take the 2 out. Yeah, if you want to be dangerous, you can always just go, oh, the 2 comes out of this parentheses and cancel. However, that's a recipe for disaster, because then you're going to say, oh, the 2 comes out of this parentheses, when it doesn't, it only would affect part of it. So yeah, I think the much safer method is just take the GCF out of both. And unless you miss something at the beginning, the GCF that comes out will always be the thing you put in. Exactly. If you put in a 2, you take out all the GCFs here, and 2 times 1 is 2 is sitting out front, and the 2 will cancel. Yeah, so after you've done the x factor, just take the GCF of both of these, and that'll cancel perfectly with the 2 you want to take out. Yeah. Okay, let's do a couple examples. Alright, so 16. 16 is 5y squared minus 8y plus 3. Okay, so what do we multiply by? We multiply by 5. We are gonna multiply the whole polynomial, although really we only care about the last term. So really you only need to multiply the last term. So multiplying by 5, we get positive 15. Okay, now what's our general form of our factored answer gonna look like?
Y plus something.
Careful, because now this is a different method, right? Our first coefficient isn't 1.
5y.
It's gonna be 5y plus something and
5y plus something.
5y plus something. We multiplied in an extra 5, specifically so we have 2 of them in there now. So now we have 5y for both. That's the big idea. We multiply in the extra 5 so we can do this. Alright, so x factor, what number is our sum?
Negative 8y.
Yeah. So we get negative 8, and the product is 15. Okay, so let's list. We have 1 times 5, 15, or 3 times 5. Since our sign is positive, we know both are the same. They add up to be negative, so they're both negative. Okay, so what are our numbers?
5, negative 5 and 3.
Yeah, negative 5 and negative 3 in either order. So, we have, and I'm going to erase these words now. We have 5y minus 3 times 5y minus 5. And our last step, which we can't forget, is divide out the 5 that we put in. And the easiest way to do that is just to say, what's the GCF of this one? 1. What's the GCF of this one? Yeah, 5. So rewriting it, we get 5y minus 3 times, and I just replace this with the totally equivalent 6.1 that we did, pulling out the GCF, all over 5, and sure enough, look, 5 and 5 cancel, and our answer is 5y minus 3 times y minus 1. And absolutely, you can multiply that together, and you get the original. Okay? So not that many steps, but pretty important. Okay? Put in an extra 5, write your general form. Cross factor, and then just divide that 5 back out. Okay? Put in the 5, cross factor, take it out. Alright, let's do another one. Because again, I know there aren't any examples in the book, so I will do lots of examples with you. Let's get some black pens here. Alright, 20. So this was the one that the book would have us guess and check that has 12 possibilities. 6w squared minus 17w plus 12. Okay. So, what will we do first? Yeah? 5? 6. And all we really care about is the last term, so we get positive 72. Okay. So, what are we going to have as our general factors?
W plus something. Yeah.
6w plus something. And? Yeah. Okay. And then?
X factor.
Yeah, with what numbers?
Negative 17
Yeah.
and 72.
Exactly, because you use the old middle term and the new last term. Okay? And so let's write out the factors. I know since 72 is positive and this is negative, I know both are negative. I'm going to write out 1 times 72, 2 times 36, 3 times 24, 4 times 18, yeah, 5, 6 times 12, 7 doesn't work, 8 times 9. Those are all my possibilities. Again, you could use a calculator really quickly and go through those.
9.
Yeah,
Negative
there you go. So, writing out our form, we get, this is 6w minus 8 times 6w minus 9. Okay, last step is,
Divide out 6.
yeah, divide out the 6. So, what was the GCF of this one?
1.
1.
2.
2. What's the GCF of this one?
3.
Yeah. So you see how the 6 isn't residing in just one of the parentheses? Part of the 6 is in one, part of the 6 is in the other. So easiest way is always, just take out the GCF at the end, and you get 2 times 3w minus 4, times, and this one becomes 3, 2w minus 3. All divided by 6, and sure enough, the 2 and the 6 cancel to leave a 3. The 3 and the 3 cancel to leave a 1, and our answer is 3w minus 4 and 2w minus 3, right? I think this is much more beautiful, elegant, shorter, pragmatic than just brutal, guess and check, hammer, mechanical, ugh. Just gives me the willies to think about it. Okay, guys, these new erasers are amazing. All right. Yeah, let's just do another example, okay? Same problems, but different method than the book. Here's 32. All right. 15y squared plus 13y minus 2. Okay, so first step, I'm going to use green. So we multiply by 15 and get negative 30. Okay, so what's our general form?
15y squared.
Not y squared.
15y
Yeah,
plus
15y.
something.
Plus something times,
13y plus something.
yeah. Okay, that's our general steps every time. Now, we cross factor using what numbers? 13y, or positive 13, and negative 30. Okay, so again, negative sign down here means one's negative, one's positive. All my factors are 1 times 30, 2 times 15, 3 times 10, 5 times 6, and that's it. So which ones cancel out, because they're really subtracting, right? Some positives and some negatives. Subtract these, you get 1, 7, 13, or 29. So which one is it?
15.
Okay, and which one's which?
15 is
Positive
positive.
15,
Why positive 15?
because we want minus 2, 13.
Exactly, you want to take away 2 and be left over with positive 13, so there's more positives. So, up here we put a negative 2 and a positive 15, and so we have 15y minus 2 times 15y plus 15, and then our last step is,
GCF.
yeah, divide by 15 by taking the GCF of each. And so rewriting it, we get, this is 15y minus 2 times 15 times y plus 1 all over 15, and look, every time cancels out, and you get 15y minus 2 times y plus 1, and again, so much shorter and more elegant than guess and check, okay? However, I get, this is complicated, this is new, okay? We'll do a couple more examples. I would recommend staying the last 15-20 minutes of class and actually practicing this rather than going home for a 3-day weekend and then Sunday night trying to do this from memory and then being like, oh my god, this is insanely hard and I don't remember. I would spend the time to at least get your feet in the water now, and then when you try it Sunday night, it'll be like, oh, this isn't so bad. Okay, I'm gonna do 3 more examples. Okay. What do you think the wrinkle we're gonna add is?
Negative.
There will be a negative, but what do you mean be a negative?
Variable in the last one.
Oh yeah, so there's gonna be one of the problems, there's gonna be a variable, a second variable, so like y is going down and y is going up, that's gonna be one of the 2 wrinkles. What's the other wrinkle?
Taking it back out.
A negative the first time?
So it's
So it could be a negative in the first term, I don't think I threw that one in here, I didn't, but that definitely could be in here. But just in general, we could combine this with past sections, well, past section is the first step always.
Combine like terms.
6.1, all about,
GCF?
yeah, that could be greatest common factor right away. So a problem like 60, you see 4x squared minus 18x minus 10. What do you think before you start anything?
GCF.
Oh yeah, what is the GCF here?
2.
Yeah,
2x, no, it's 2.
yeah, no 4, so it's just 2. So you take out the 2, and then you have 2x squared minus 9x minus 5, and now you factor that inside just like you would any other problem. But every problem after about 50 or 60 is then gonna have a common factor. So that's it, first step, 6.1, take that common factor out, and it doesn't affect anything for the rest of the problem, it just lives outside and is still there in the answer. It doesn't actually change anything.
So you can still take that and then do the hokey pokey with it,
Exactly.
and then just put
I
the
just
2.
love hearing people say that, yeah, exactly. So this is the part we're trying to solve now. The 2's gonna be there in our answer, keep it the whole time, but this is what we're dealing with. So what do we do?
The hokey pokey.
Yeah. So what do we multiply by?
4?
2.
It would have been 4 up here, and that's why, Nick, you asked if we don't take out the GCF, you could still do the hokey pokey with a 4 there. The problem is when you get your answer, it won't be completely factored. There will still be extra numbers in it, but it'll work. However, if there was a y in all of these, you can't factor it. You don't have a method to factor that, to take those out. So that's why if you don't factor out all the variables, no, there's problems. But if you don't factor out all the numbers, you could still use the hokey pokey and get an answer. Okay, so here though, after we factor out the 2, we multiply by just this lead coefficient.
Okay.
So we get negative 10, all right? What's our general form gonna be? I leave the 2 there, and then
2x squared.
not x squared.
2x
Yeah,
minus plus something
yeah,
times 2x plus something.
exactly. So that's what our answer's gonna look like, and then we'll divide by 2. Is that okay? So what is the sum and what is the product?
9, 8, 9,
Exactly. We use the old, middle, and the new last. So negative 9, negative 10. So 1's a negative, 1's a positive, and we have 1 times 10 or 2 times 5, so it's, and which one's negative and which one's positive?
Negative 10,
Yeah,
positive 1.
negative 10, positive 1. So this is 2 times 2x minus 10 times 2x plus 1. And then what I'm going to do is that last step, that same last step as every time.
Divide by 2.
Yeah, so I'm going to do 2x minus 10, 2x plus 1 divided by 2. Now here's the small problem people do, is they see a 2 out front and they go, oh, okay, cancel it. Now this is correct. This is a correct answer. However, it's not complete. I said factor it completely, and there is still a 2 inside of this that needs to be taken out. So this is the result you would have gotten, Nick, if you hadn't taken the extra 2 out. You would have gotten this. It's correct, it is factored. However, it's not completely factored. It's like partially reducing a fraction and leaving it as 2 over 4. There's still one more step until you're a half. So that's why here, always I take out the GCF is 2. I take out the GCF is 1. And I would not cancel this yet. It doesn't matter if you did. Totally fine if you did. You get the same answer. Okay, so I would write it as 2 times, this becomes 2 times x minus 5. Now divided by 2, and one of the 2's cancels, but you still have that 2 out front. Whatever you take out here as your greatest common factor will absolutely for sure show up at the end, because it was in common with the whole thing. You took it out. It's being multiplied by the whole thing, so it should always be there at the end. for sure, okay? Yeah,
So I literally kept that 2 out until the very end.
yeah.
And then I just put it back in. Like, is that gonna be wrong at all?
I mean, no, but I would say you'll make more mistakes that way, because if that 2's not there, here or here, or here, or here, it's really common for people to just cancel out and be like, alright, my answer is, and it's not there at the end. But you absolutely could factor it out at the beginning and then just write it in at the end. That's totally correct, it's just leads to more mistakes, that's all. Alright, so we'll do 2 more. This one is now even bigger GCF. So this one, if you don't take out the GCF, you actually can't solve it. This one, that last one you could. But this one, because it's got an extra variable, none of our strategies would work. Okay? So what's the GCF here? 20z. We could take out a 10, we could take out a 20, we could take out a z, but the greatest thing that we could take out is 20z. Okay? So we get the 20z out front, and what's on the inside is what we're factoring. 4z squared plus 4z minus 3. That's what we're going to factor. Okay? As though the other stuff wasn't there in the first place.
Times 4.
Yeah? Times by 4. So times 4, we get negative 12. What's our general form look like?
Z plus something.
Not z.
4z.
4z. We multiplied in the extra 4 just to have that. Alright, and what's our cross factor gonna be?
4z.
Well, that's getting the whole term, but we're only looking at the coefficient.
Plus 4.
Yeah, plus 4. Negative 12. Okay? So, we have negative for our product, so 1 is positive, 1 is negative. We have either 1 times 12.
Positive 6 and negative 2.
Let's see, so difference is 4, so positive 6, negative 2. Perfect. I'm curious with all these people that are leaving, are they just quitting or math, and they're like, I don't get it, or are they just experts? Yeah, I'm curious what their mindset is. It's like, I don't get this, so I'm leaving, or I get this so much, so I'm leaving.
4C.
I'm curious. Anyways, okay, so we put these back in, so now we've got 20z. I mean, it doesn't hurt my feelings, I just really like, I'm curious in my head, like, are they just quitting or not? I don't know. Okay, so that's what it looks like, but we can't forget to take things out. Right, so at the end, we put in an extra 4, so we're gonna take out a 4. Again, you can cancel it with this, that's not wrong. However, there would still be things left over inside, so it wouldn't be completely factored, so you wouldn't be completely done.
GCF is 2.
Yeah, so GCF of this one is 2. GCF of this one is 2. So it's 20z times 2z minus 1, times 2z plus 3, all over 4. And that's where the 2 and the 4 cancel, and the 2 and the 2 cancel. And so that 20z that we took out at the beginning is still there for sure. Didn't disappear. And then we have the leftover part factored. And you can always multiply this back together and see if it works. Okay, we're going to do one last problem, and as you guessed that, the last problem is just going to have x's and y's. That's all. Otherwise, it's exactly the same problem as the others. Okay, so here's 82. So this is as hard as a problem could get in this section, other than maybe having a negative out front. That would be one step further. But we're taking out a common factor, and there are 2 variables. Okay, but otherwise it's the same method, So what's our GCF here?
3.
Yeah, so just GCF of 3. We take that 3 out, we're left with
8x squared
Yeah,
plus xy
yeah,
minus 9y squared
perfect, and then,
times that by 8.
yeah, so we times by 8, we get negative 72y squared. So, what's our general form look like?
8x squared plus something times 8x squared plus something.
So, two mistakes with that.
Oh, yeah.
So not 8x squared, because 8x squared times 8x squared would be 8x to the 4th. So right, it'd be just 8x times 8x, okay? And then what's the second term?
Why?
Yeah, something y, right? So because we have the x's decreasing in order, both of the first terms have an x. Because we have the y's increasing in degree, both of the second terms have a y. So we have 8x plus something y, 8x plus something y. And now we can factor it just like normal. Okay, what's the top?
1.
Yeah, bottom?
Negative 17.
There we go. So big numbers, that's okay. Negative, so we know one is negative, one is positive. We list all the factors. Again, you can use a calculator. Just go 72, hopefully everybody knows 1 times 72. But then you go 72 divided by 2 equals 36. 72 divided by, 3 is 24. Divided by 4 is 18. Divided by 5, decimal. Divided by 6, I get 12. Divided by 7, decimal. Divided by 8, I get 9. Divided by 9, and it's 8, so it repeats. So with a calculator, I punched in, I think, maybe 8 things, and I got every possible factor. And you only have to go as far until it repeats. Okay, so
Negative 72 plus 1.
that would be negative 72 plus 1 would be negative 71 up here.
Be, positive 9 and negative 8.
Yeah, it'd be the 8 and 9, because we're really doing subtraction here, because they're canceling with one another. So the difference of these two is 71, 34, 21, 14. So you see the biggest difference is when it's 1 times the number, and the smallest difference is when you have these numbers close together, and the difference there is 1. So which one's negative and which one's positive?
9 is positive.
9 is positive, because when we add them together, we want more positives to be left over. So we have 3 times 8x plus 9y, and 8x minus 8y. And then the last step is always,
Divide.
GCF.
divide by, or we'll take out the GCF. What are we gonna divide by?
8.
Number
8. Yeah, so we take out the GCF. The GCF of this is 1. GCF of this is 8. So now we get 3 times 8x plus 9y times, 8 times x minus y, all over 8. And look, the 8's cancel. So the answer is 3 times 8x plus 9y times x minus y. Okay? So you got about 15 minutes. I would strongly recommend practicing a few problems of this right now before leaving and waiting 3 days to practice. Strongly encourage that. That's it. That's the Hokey Pokey.
Can you get some